Good morning, everyone. My name is Marc Caruso, and I'm going to be presenting to you today design considerations for Oracle Applications Unlimited on Oracle Cloud Infrastructure. I'm the Chief Technology Officer of the Applications Practice at Data Intensity. My responsibilities include managing all of our Oracle-focused applications, both on-premises as well as cloud apps. I've been working with the Oracle eBusiness Suite since 2005 and Oracle Technology since 2004. So I've got a lot of experience building and managing highly available, complex ERP solutions. I'm going to start Oracle Velocity program. Because we're in Velocity and Managed Service Provider program, we can do both implementation as well as ongoing support for Oracle Cloud. Our big value propositions are that we can support customers up and down the stack from infrastructure all the way up through functional application support, as well as through their entire application lifecycle from implementation through ongoing support and the upgrade process. We've got over 600 customers globally. We supported over 3,000 implementations. Today, we manage over 15,000 environments across those 600 customers. We performed over 200 full cloud migrations for customers, many of which have gone on to OCI. We've got about 800 people worldwide. We've got more than 20 Oracle Cloud Infrastructure certified solution architects and more than 2,800 staff certifications. As you can see from the list here, we do support a wide range of Oracle products and technologies. Most recently, we were named Oracle Excellence Partner of the Year for Australia and New Zealand. We support a full range of managed services and professional services solutions, from implementations and upgrades through health checks and total cost of ownership analyses. We also provide ongoing support for customers running any sort of Oracle software or technology. Most of our work today is spent helping customers understand which cloud option is right for them, whether that's infrastructure, platform, or software as a service, and the roadmap for them to get there. Today's presentation is going to be focused on design considerations for Applications Unlimited programs. As I mentioned, most of my background is in the eBusiness Suite, but I do have some experience with PeopleSoft, Siebel, and JD Edwards. And a lot of the design principles are similar across all of those technologies. So the first question we have to ask is, why would you consider Oracle Cloud Infrastructure for Applications Unlimited? One important thing to know is that Oracle is committed to premier support for Apps Unlimited programs through 2030. So that means if your solution's working right for you, maximize your investment in it. You can also get the benefits, many of the benefits of software as a service without having to re-implement your entire ERP. The key things that we're going to be focused on today are performance, scalability, flexibility, and security, along with availability. And one of the key themes that we've heard from our customers is it's not just about lifting and shifting as is. It's about moving and improving and giving your end users something at the end of the day that isn't just about moving it from one place to another. It's about giving them some additional functionality, some additional capabilities, maybe faster cloning, maybe more improved ability to provision environments and things like that. The other thing about OCI is that it is a compatible supported solution. So all of those Applications Unlimited environments and all the development teams working on them are required to ensure that they are supported on Oracle Cloud Infrastructure. And a lot of those teams are developing automated tooling to help customers get into OCI more easily and help them perform maintenance once they're in OCI more easily. That said, there are some restrictions on migrating, and we'll talk about those as we go through the presentation. The last thing for customers to understand is it is possible to achieve a return on investment for a project like this. Typically, we see a total cost of ownership that's significantly lower than on-premises solutions, anywhere from 30 to 50% lower, in fact. And if you consider both the hard and soft costs of a migration, then that means considering things like cloning performance, the availability advantages of being in public cloud, and a lot of the soft costs that you'll be saving in terms of staffing and data center expense and hard costs associated with data center expense, the TCO is usually pretty compelling. So building that business case and being able to justify a project with a return on your investment. One of the biggest things that customers sometimes don't consider is being able to eliminate some of their spend on perpetual licenses. We've worked with a lot of customers along with their Oracle reps to take some of their shelfware and convert it into cloud spend. So there's some general requirements for Applications Unlimited. Availability, obviously, making sure that there's some level of local high availability as well as remote disaster recovery. There is a difference between those two things because with local high availability, there typically isn't a significant amount of reconfiguration that has to be done. You don't have to repoint things to a new location. You don't have to reconfigure any sort of interfaces. You don't have to redo your DNS. It's contained within a particular geography that doesn't require those tasks. Performance. Some OLTP systems do require a decent level of performance, both from a compute perspective as well as a storage perspective. One of the big things that we see driving expense for customers is storage and I/O. And especially with some of the other cloud providers out there, I/O can be a very, very expensive part of a cloud initiative. One of the nice things about OCI is that storage requirements are either built into the VM with NVMe or provisioned either in block or file storage at a very inexpensive cost. And it's all flash storage, so it's all very highly performing. You don't have to figure out what kind you need. Manageability is obviously a key thing. So one of the big things with ERP systems is you have to keep them patched. You have to clone them. You have to give the business the ability to advance functionality. And there's a lot of legwork involved in doing that. And that's often at odds with both availability requirements and security needs. So increasing availability, increasing security can sometimes add a lot of cost to the management side of things. So if you don't have any sort of automation capabilities or orchestration capabilities, that can add to your total cost of ownership and reduce the return on investment. Scalability. So being able to add and remove environments as they're needed without having to keep a permanent spend for high watermark. Being able to add system resources as you need to. And being able to do that with regard for your application and technology licensing. And the last piece is security. Most of our customers, and we internally at Data Intensity, take a defense in-depth approach to security. Compliance is obviously a big concern for our customers with GDPR requirements and all the things that you need to do around privileged access management and auditing and things like that. So having a cloud platform that can support all those needs is critical. From a topology perspective, all of these applications work very similarly. 3-tier architecture, web server, application server, database server, and then some level of shared services around them. The key thing to understand is that Applications Unlimited software is not cloud native and therefore has to be treated differently from your typical cloud use case. It used to be a few years ago that customers would ask me why they can't automatically get high availability when they get migrated into a public cloud platform. And so we've done a lot of education over the last few years to get them to understand why that's the case. Some of the things to consider are your software versions. So making sure that they are compatible with the operating system releases that are available on OCI. And if they're not, making sure that you have the ability to develop custom templates and images that you can use in OCI for those older releases. So if you're still on Linux 4, God forbid, or Linux 5, being able to create images for those that you can then leverage within OCI. Obviously, your software licensing, whether you're going to bring your own licenses or whether you're going to use some subscription licensing with Database Cloud Service. 3 tiers for a typical Applications Unlimited environment: the database tier and the application tier. Usually the web tier and the app tier are collapsed. Database tier usually requires high performance compute and storage, whereas the application tier usually has load balancing requirements and some level of shared storage. Many Applications Unlimited environments have some component that's exposed to the public internet, so that's a DMZ tier. Obviously, their security requirements are very tight. And then things like file transfer. So most Applications Unlimited, if not all, need some way to be able to send and receive files. They need to be able to look up things with DNS. They need to be able to maintain time with NTP. They need to be able to send emails in a lot of cases. And making sure those use cases are all considered. And then the last piece is user access. So users being able to actually access the system, whether that's direct connectivity or virtual connectivity using a virtual private network. So when we start thinking about application unlimited on OCI, there are a lot of questions that need to be answered. First and foremost, are your versions compatible? In most cases, the answer will be yes, unless you're on a very, very, very old release. In cases where you may not be compatible, there are usually some things that we can do to get you to a minimum release that will allow you to be migrated. Related to that, are you going to move and improve, or are you going to lift and shift? For customers that are on the latest release, a lift and shift may be adequate. I would recommend that even in those situations that you try to think of 2 or 3 things that you might be able to deliver your users, things like mobile functionality or a new take on the GUI that will at least make them realize that something has been done other than just moving it to a new infrastructure paradigm. There are a lot of considerations to be made around whether a customer uses infrastructure as a service, platform as a service, or a combination of the two. This is typically one of the biggest decisions that a customer will make. Obviously, with infrastructure as a service, that means that you're going to still have a significant amount of responsibility around the actual software maintenance. Whereas with some of the platform services, there's less of a need to be focused on actual software management. And with the advent of autonomous database, whether that's the autonomous data warehouse or autonomous transaction processing, there's going to be less and less of a requirement to have technical resources at a platform level. If you do use PaaS, you're going to need to think about whether you bring your own license or use subscription licensing or a combination of the two. We've done a lot of work with customers to help them optimize their licensing, doing things like license conversions of named users to processor, or vice versa, processor to named users, so that they can focus their subscription licensing in either production or non-production and disaster recovery, where they have all of one license type that they can focus on one particular use case. And then everything else will be subscription. It's incredibly important for customers that have requirements that are seasonal, or for customers that have a lot of project requirements where they may need a lot of burst capacity for non-production. Another thing to think about is how you can optimize your environment strategy for cloud. That means that your typical environment strategy may be to develop code in dev, migrate it to test, do a user acceptance test in UAT, and then migrate to prod. But you may have a lot of different constituencies vying for non-production space. One of the big benefits of cloud is being able to provision environments on demand. So you need to think through how you're doing your regression testing and how you're doing your user acceptance testing, and how you take all of those disparate development environments and get them on the same track. There's a lot of real advantages to using public cloud, and individual development teams will really benefit from that capability. You need to think through your OCI network configuration, whether that's going to be standard, standalone, or extension of your on-premises network. How are you going to leverage tagging to manage your environment? So one of the things that you can think about is tagging by application, tagging by department, tagging by application type. That will allow you to have some additional information around cost controls. So as you provision storage and compute, being able to tie those system resources to an actual application environment or a cost center or things like that. And then the last piece is how you're going to leverage identity and access management paradigms and potentially compartments in your environment. There are some real limitations to using compartments and some advantages too, and it's important to understand the differences with both. Who are you going to actually allow to provision new services and new resources? How are you going to maintain cost control in the environment? All of those things really need to be considered when you're developing your identity and access management policies. So now we're going to get into a few key topics related to the availability. Typical failure points within a traditional data center environment usually fall into 2 categories: infrastructure and software. So from an infrastructure perspective, you've got things like data centers and networks. If you're virtualized, you'll have server clusters, you'll have the individual servers and the way that they're configured, as well as storage devices. All of those things have failure points, and to truly calculate the potential risk of failure, you have to take each one of those failure points and multiply it. And as you do that, even for systems that have 5 nines of availability, by the time all is said and done, you're typically getting to a much lower level of availability than you started out with. Public cloud and OCI in particular help to address a lot of these issues, both with the way that the individual pieces of infrastructure are configured, as well as through the data center design. To mitigate some of the issues with dealing with legacy software, and a lot of the software that we're talking about with eBusiness Suite and PeopleSoft and Siebel and JD Edwards are 10, 20, even more years old, and follow a very different development paradigm than the software that's developed today on cloud. So things like application servers, the application software itself, how that's deployed, the way that the databases are deployed, how they share file systems, the shared services that they use, things like DNS and LDAP and NTP. And then situations like human error that can have impacts on software as well. Somebody fat fingers something, you have to roll back. Somebody introduces some sort of an issue that somebody doesn't catch for 24 hours. So all those things have to be considered when you're developing an availability strategy. From an infrastructure perspective, typically the risk of data center or network failure is fairly low. Mitigation within OCI can be done with things like availability domains and regions, as well as fault domains. There are a lot of dependencies from a data center perspective on things like the power grid, the HVAC systems, things like that. And from a network perspective, around things like physical power and cabling, network firmware, and things like that. So we have specific controls that we use to mitigate these failure points. From a server and virtualization perspective, we look at the servers and the server clusters. The server clusters also use storage in some way, shape, or form, as well as software. We mitigate failure of those systems by using things like fault domains, as well as redundant infrastructure, redundant guests, redundant storage. From a software perspective, that's typically the area where things are more likely to fail. You have file systems fill up very quickly, they cause a database crash. You have an application server that somebody runs a job that causes the application server to slow down significantly, basically makes it unusable. Those types of things are very easily addressed by things like real application clusters, by WebLogic clustering, by things like DataGuard and Active DataGuard. And with cloud, because you can provision infrastructure so quickly, there are a lot of creative things that you can do to provision infrastructure on demand in the event of an issue, so that you're not paying for actual running components all the time. Now, that doesn't help out customers that feel that they need an active-active type of configuration and they need 3 or 4 nines of availability. It does help customers that don't have that type of budget or that type of ability to buy that level of software, and allows them to provision on demand, so that in worst case scenario, they'll be able to get themselves back up and running in a few hours and be able to support a 99.5% level of availability. So a key thing is to be able to work with your business to understand what your acceptable typical availability and worst case availability is to inform your design decisions. Now, with service level agreements, obviously there's usually a penalty associated with violating an SLA. But if that penalty doesn't make up for the amount of revenue that you'll lose with that downtime, you need to think about how you can justify provisioning additional resources to give you the real world availability that the business is going to require. And with public cloud, you have a lot more tools at your disposal so that you don't have a large upfront cost to be able to do that. So the first thing we're going to talk about is OCI data center design. There are three key things that you need to understand. The concept of a region. A region is comprised of 3 availability domains. Availability domains are separate data centers with separate networks. Regions provide geographic isolation and are typically used in conjunction with each other for disaster recovery and asynchronous data replication use cases. Those availability domains are typically comprised of 3 fault domains. Availability domains provide data center isolation and do work well with HA use cases. That's because there are high bandwidth, low latency interconnects between those data centers, and they're relatively close from a geographical perspective. And then the last thing you need to understand is the concept of a fault domain. This is something that was recently released in OCI. And fault domains refer to groupings of compute infrastructure. This protects against both device and rack failure. It also protects against downtime due to proactive maintenance or compute failure. So you can actually use fault domains to get around Oracle maintenance windows. For compute, there are some key things to understand. Deploying cross-availability domains is key in terms of redundancy. Compute resources are specific to an availability domain. So if you want to have redundancy, you have to provision those resources in multiple of the 3 availability domains. So typically we'll see customers have availability domains 1 and 2, and if they have redundant application tiers, they'll deploy application tier 1 in availability domain 1 and application server 2 in availability domain 2. It's also important to understand that platform as a service solutions for standalone or rack configurations are specific to an availability domain. So if you are running platform, it is critical to understand that those solutions can fail and that you still need to think about high availability as you do your designs. One exception to that is the autonomous paradigm, which has a higher level of availability automatically built in. You can use asynchronous or synchronous data guard or active data guard replication for database tier redundancy across availability domains. That will basically give you a significant improvement in terms of how long it takes you to recover from a database failure. You can also configure things like fast failover to help with automatic recovery as well. For the application tier, we're typically using storage replication to provide that level of redundancy across availability domains. And as we'll see later in the presentation, there are some trade-offs in terms of manageability versus availability when it comes to storage. You need to ensure that your load balancing is properly configured. There's several different options for load balancing configs that we'll talk about later, including public or redundant private load balancers. And then also making sure that any shared services that you have in your environment are also configured redundantly across availability domains. So that's things like FTP servers or multi-protocol file transfer solutions, things like email, DNS. If you have an LDAP solution for logging into your servers, you want to make sure that that's redundant. And also making sure that any sort of single point of failure integrations are considered as well. From a network perspective, virtual cloud networks apply to a given region. So that VCN goes across all of the availability domains within a region. Internal networks are isolated within an availability domain. So if an internal network of availability domain 1 has an issue, the network in availability domain 2 theoretically is not impacted. That's why it's really critical to deploy compute resources across availability domains. You can also configure load balancers across availability domains as a public load balancer. Or, if you want a more secure option, use DNS load balancing with multiple load balancers within an availability domain. That's referred to as a private load balancer solution. Typically, customers are using reserved IP addresses in DNS to achieve a passive high availability if they don't want to opt for an active high availability solution. And then to protect against any sort of regional failure, and you can think about this in terms of any sort of widespread power outage in the summer or an active nature, hurricane within a particular region, you can enable disaster recovery in a separate region. That's our recommendation from a disaster recovery perspective. One of the things that you can do, though, to minimize your spend is to leverage Terraform build scripts to be able to create your infrastructure on the fly and simply restore from backup. You can also replicate your data to a separate region using asynchronous data guard replication, and then have scripts to be able to increase the size of that so that you're not overspending on your replicated environment, but only increasing that spend when there is an actual DR test or an actual failover. As I mentioned, load balancing can be configured either as a public or private load balancer service. Public load balancing use cases are required anytime you need access from the internet. In that case, you configure an active load balancer in a single availability domain with a second passive load balancer in a separate availability domain within a region. So that way, if availability domain 1 goes down, that passive load balancer will take over to the secondary infrastructure. You can also use private load balancing in some of the same ways. So if you only have internal use cases where only internal users who are coming over VPN or a fast connect network will be accessing your application, you can create an HA config using custom DNS with round robin using multiple load balancers within single availability domains. And one of the key things that customers often forget, they'll design for high availability within OCI or whatever cloud platform they're working on, but they won't think about the actual ingress for user access. So if it's not an internet-based application access and you're going over a VPN, you'll want to have multiple VPNs to multiple endpoints in different availability domains. You can also do a similar configuration with Fast Connect, and this is even more important, where you can contract for multiple physical circuits through multiple partners, connect through different availability domains within a region, and even different routers within that availability domain. We typically see customers leveraging BGP or Border Gateway Protocol to be able to load balance. You can either do that in an active-active scenario or an active-passive scenario. Obviously, if you're using active-passive, you're going to want to test that regularly to make sure that it works as expected. Let's talk about storage. There are really three key types of storage that you're going to be working with. One is object storage. Object storage is used for any sort of object requirement, any sort of backups that you would typically take. Object storage exists within a region and is replicated across devices and availability domains. Block storage, on the other hand, lives within an availability domain, but it can't be shared across availability domains. So there are some restrictions there in terms of how you leverage block storage. And then file storage lives within an availability domain, but it can also be shared within a region. So in some cases, you have to look at the trade-off between the performance of file versus block and what makes more sense, both from a performance perspective as well as from a manageability perspective. If you have 6 application servers, all with a separate block storage volume, and you have to patch 6 times versus having a single volume of file storage that you can patch once, that's obviously a significant management overhead. For NVMe local storage, especially for bare metal systems, utilize RAID arrays. And it's also important to make sure that when you're taking backups to object storage, that you do that and take your backup in another availability domain from the one in which your resource lives. So if you have a database that's in availability domain 1, you don't want to store your backups to that database in availability domain 1. You want to store it in availability domain 3. From a performance perspective, there's not a lot to talk about because OCI is one of the highest performing public clouds out there. NVMe storage, flash storage, having flat network, no oversubscription, noisy neighbor syndrome, the fact that there's less than 500 microsecond latency between availability domains, performance isn't sacrificed for availability. You need to understand your I/O profile to know if you benefit from something like an exacloud service, as some of the higher end database solutions will really give you a pop in terms of the performance. Obviously, there's a significant expense to that, so you have to be able to do the trade-off between an exa solution and a traditional database cloud service solution. Manageability is a key thing that customers often overlook when they're doing a design like this. They're overly focused on availability and not as much focused on how much that environment is actually going to cost them to operate. One of the key things to think about here is automation and orchestration. This is something that customers usually forget to think about when they're looking at a public cloud solution, and it is part of the initial upfront investment. You can either build that yourself or use a service provider like us to be able to deliver that type of solution on your behalf. There are trade-offs using pure infrastructure services versus platform services. We've had a bunch of customers ask us if there's lock-in by using database cloud service, and the answer is no. However, one of the things that happens when you move over to DBCS on release 12 is that you're converting your database to a multi-tenant database. So it now is a container database. If your on-premises database is not, there's obviously going to be some limitations there in terms of how you do your cloning. There's also going to be a requirement that if you did want to take that environment out of Oracle Cloud and convert it back into an on-premises solution, that you're going to have to disable multi-tenant. And you would have to do some work around that. Last thing to mention is autonomous. There's been a lot of talk in the market lately around autonomous. We at Data Intensity are actually using autonomous technologies ourselves for our own business. And some of the big things that appeal to us around that are the fact that they are self-patching, self-tuning, self-securing, and really take a lot of that technical burden off of our technical resources. It allows them to manage a lot more systems than they used to be able to manage, and it allows them to provide a much more high quality level of service. And it allows them to really focus at the application layer. However, most of those solutions are not available for Applications Unlimited yet. A lot of the availability and security decisions that customers make have significant downstream impact to the management of the system. So your identity and access management policies are one example of that. How you decide who gets access to be able to create and change resources is going to have a significant impact on your overall cost management ability. How you do your tagging within the environment is going to have a significant impact on how you're able to build back the business for things like environments on demand. How you configure your fault domains, your availability domains, and your regions are obviously going to have an impact as well. Because if you're focused entirely on a single region and a single set of availability domains, that's going to be easier for you to manage than having multiple regions. But there are obviously trade-offs there, and you need to make sure that your business owners understand what those trade-offs are. Use of compartments is another thing that customers often ask us about. Compartments are logical groupings of resources, where you can have finance and operations own separate compartments within a single tenancy and not be able to see the other system resources across those different compartments. So that's obviously a big benefit in organizations that have hard lines of demarcation, but obviously it's also a drawback. Compartments can't be destroyed once they're created, and so you'd have a lot of rework to do if you wanted to redo your compartment strategy after the fact. Creating the number of subnets, figuring out what your network design is going to look like is probably going to be very similar to what you do on premises. Usually we see customers that have separate networks for database, private application tier, public application tier, management infrastructure, etc. Where we do see customers having a little bit of a tough time is the granularity of the security lists, and we'll talk about this in a little bit more detail. So from a compute perspective, how you use your fault domains, your availability domains are going to have an impact on the level of the amount of management work that you need to do to perform maintenance in your environment. So if you're doing patching, if you're doing cloning, making sure that you have the right mechanism set up to be able to do that quickly and easily in a repeatable way. And what we're really talking about here is automation. And if you don't have automation built, it's important to think about how you're going to be able to build that as you're going through a cloud migration. There are some trade-offs between bare metal and virtual machines. For example, virtual machines can't be resized on the fly, whereas bare metal can. So depending on your particular use case and your requirements, you may want to put all of your non-production environments on a single set of bare metal that you can scale up and down versus having them isolated on individual virtual machines. You can only have one Oracle home in a virtual machine versus on bare metal where you can have multiple. So you can think about it in terms of multiple environments on a single bare metal server with multiple Oracle homes versus a single virtual machine that's not scalable that can only have one Oracle home on it. So that's one database per virtual machine. Works similarly with a database cloud service as well. From a storage perspective, looking at block volumes, being able to clone block volumes is something that is a very powerful feature. It really helps with the cloning process of the application suite. Looking at block versus file storage. So if you provision block storage and you have a highly available solution that's across availability domains, that means that you're going to have separate block volumes with copies of your application tier software that you're going to have to patch independently. versus having file storage that's shared across availability domains that you're patching once. I mentioned before that file storage lives within an availability domain but can be shared across ADs within a region. And that is very, very important. And that's really the direction that we're going from with our architecture standards using that file storage. That said, there may be some use cases with high volume directories like the Apple CSF directory within a business suite, for example, where if you are a very large implementation with high volume, you may not be able to use that effectively. So that is something that, that you would need to consider. Scalability is obviously one of the most critical aspects of moving to a public cloud solution. I mentioned before that there are some scaling limitations within database cloud service virtual machines. The number of CPUs that you allocate initially is set when you use virtual machines. Whereas if you're using bare metal servers, you can scale those up and down. This has implications for licensing as well as for management. One other thing to understand is that you can't resize block storage in place. So if you do need that requirement, you should use a logical volume manager or something like ASM, or you can use file storage. If you're using infrastructure as a service, you really need to think about software licensing, because scaling obviously requires licensing, especially for something like Oracle Internet Application Server where there's no past subscription option available. If you're bursting capacity from an infrastructure standpoint, you also need the licensing. And so that creates a bit of a conundrum for especially things like online retailers that have seasonal demands where they have to size their licensing for the peak rather than for their day-to-day. You need to think through how you're going to automate that scaling process. And I keep coming back to automation and orchestration. And that really is the key to the success of a project like this. You need to consider both the expansion use case as well as the contraction use case. So there may be situations where you're only using 20% of your processing, and you may want to scale back on the number of processes that you have allocated, especially if you're using subscription licensing with database cloud service. From a security perspective, I've talked through a little bit about the identity and access management policies, as well as the compartment configurations and the trade-offs there. We've talked about the subnet design and how we would typically see that within a customer. You also need to think through public and private network configurations. So if you do have a dedicated fast connect, you do have the ability of accessing public services like object storage over that private line. And there are ways to design for that. You need to think through the granularity of your security rules and how many of those you want to have deployed in your environment, especially if it's a private environment with no public access. The level of security rules you need to implement if you want to do that at a port level is going to take a decent amount of time and some management. And obviously, when there's change management and release management going on, there's usually more troubleshooting involved as those ports get updated, the software gets updated. And then looking at your load balancing, so whether you're going to use public or private load balancers and then how those get configured. Some other things to think about that aren't necessarily directly related to OCI, but that most customers are thinking about right now, things like privileged access management. So one of the biggest threats today is insider access to data. So protecting your data from your DBAs or from your functional analysts. Making sure that you have mechanisms in place to both prevent data access as well as audit data access. Password and key management obviously becomes a pretty critical thing, especially if you have things like database vault that are deployed. And then the last thing is the impact of autonomous database solutions. So with autonomous, a lot of those security concerns are going to be mitigated because the autonomous system will automatically apply security patches and make security recommendations as it learns about how you're using the system. So just to show a diagram of what we've been talking about today. The diagram here shows a single Oracle Cloud region with 3 availability domains and infrastructure deployed across multiple subnets within those availability domains. As you can see there, there's a single virtual cloud network within the region, and customers accessing over a Fast Connect and a VPN. And that's typically what we're seeing. We'll see customers have a single Fast Connect with the internet-based VPN as a backup. Now we'll get into the case study. The case study is designed to show both the business benefits as well as what we did technically for this migration. This is a real-world migration that we did, so it should be applicable to some of the folks who are in attendance today. So the business goals were to provide a solution that was cost-effective. So this customer was a rapidly growing organization, actively acquiring companies. They didn't want to have to buy licenses in advance. They wanted to be able to pay for use, but they did want something that was highly performing. They wanted something that was compliant, and something that they were going to be able to grow with. They wanted something flexible and scalable. They knew they needed a manageable solution that they didn't have to pay a lot of attention to. They wanted something secure and highly available. So from a licensing perspective, they were limited in terms of what they could do. So I mentioned before, being able to use that automation and orchestration to very quickly provision resources in the event of a disaster was something that was very appealing to them. They also wanted to make the business feel like they were getting a new application. We won't be getting into a lot of the move and improve side of this project since it's really focused on OCI migration. But it is one thing that I would advise everyone who's listening to really think about if they're considering a move to public cloud. It's not just about moving from point A to point B. It's about making your end users feel like they're getting something out of the project. The customer environment that we're talking about was an eBusiness Suite 12.2 environment on a 12c database with core financials, order management, service contracts, projects, as well as DMZ and mobile. They also ran Oracle Business Intelligence applications and Oracle Access Manager. About 800 users, 400 gigabyte database, and a number of different integrations to third-party SaaS applications. One of their big challenges was their non-production environments. Because they had so many things going on, they had very limited licensing, they were really running up against some significant performance bottlenecks in non-production. And they had an inadequate disaster recovery solution. Their disaster recovery was to restore from backup. So the pain points were really around requirement for additional eBusiness Suite environments. They didn't want to buy more technology licensing as the world is going towards a SaaS and subscription type model. They didn't want to invest in hardware, and they really needed to get a significant improvement to their recovery point and recovery time objectives for the disaster recovery. They chose OCI in part for the compatibility and supportability, but more so for the price and performance and the subscription software licensing. The tooling and automation was a benefit. And part of the reason that they chose us as a provider was because we offer a significantly higher level of automation around OCI than even Oracle does today. Getting started with the project, there were really three key goals: offsite backups, disaster recovery, and burst environment capacity in non-production. And some of the things that we took advantage of was pay-as-you-go licensing, subscription database licensing, and being able to provision new development environments without the customer having to buy more software. One of the key things, we've already talked through some of this, making sure that high availability is built into the design from the outset, looking at your shared services and not thinking about all those things that you need, and making sure that if you are extending your internal network, that your infrastructure teams are prepared to support you in that endeavor. Once you get your OCI environment set up and ready to go, and you say, hey, I need to be able to access XYZ, and your IT department comes back and says, well, we didn't even know you were doing this project, so we can't help you for 3 months. You don't want to get caught in that situation, so plan for it up front. Making sure that you've considered all your integrations and your customization. So all those Chemleys are really important. Making sure that you take the time to invest in orchestration and automation, or work with a partner that has those capabilities already. Obviously, license management is another thing that customers are oftentimes, and especially in this case, very concerned about being able to leverage subscription If you have bring your own licensing, optimizing those on-premises licenses to your best advantage so that they work well with your cloud solution. And then looking at that upgrade solution. So not necessarily doing a full-blown software upgrade, but applying security patches, getting your database patched up to the current level so that you're not being hit with extended support fees, implementing some sort of mobile functionality for customers, things like self-service time or expenses or things like that. Then you have to think through all of the different configurations, identity and access management, so how you're going to configure your policies, what groups you're going to set up, the users that belong to those groups, whether you're going to use compartments or not. In this case, we basically had two compartments, one that was a lab environment and then one that was, quote, the production environment. And that production compartment had all of the environments for eBusiness Suite, including production, test and development, and all of the other dev environments that were provisioned. From a network perspective, looking at your subnet policy, a lot of this we have templates for, so we used our reference architectures to be able to deploy all of this, looking at the different shapes that are available and what makes most sense for the customer from those canned shapes, and then applying licensing to it. And then looking at storage and making sure that you have the right storage based on your I/O profile. Getting all your backups set up, making sure that those backups are going to the right place, that they're able to be restored, and that you can do that automatically. So we've talked through a lot of this already in this presentation, but some of the specific considerations that this customer went through were manageability versus high availability, looking at the storage config. So they opted to go with a more manageable solution using the file service along with private load balancers. From a licensing perspective, looking at database cloud service versus infrastructure as a service, given that there was no infrastructure, no internet application server subscription option through Oracle, they were limited from an application perspective. They did wind up buying some more licenses for application server to support that requirement, but it was much less expensive than what it would have been had they had to buy both application server and database server licenses. Initially, this customer did a hybrid solution where they had disaster recovery and non-production in Oracle Cloud and then migrated production at a later date. So there was a period there where they were not cloning those non-production environments. They had converted them and encrypted them with TDE. Obviously, they became pluggable databases in Database Cloud Service. So there was a period where we were in a bit of a freeze until a production environment could be migrated and migrated to a pluggable database as well. Most of the integrations worked seamlessly without any sort of changes. We took the opportunity to optimize the file system layout for the customer at an application tier level, and do some other work in terms of how files are moved in and out of the system that did require some changes, but kept those at a minimum as well. Their challenge also was, part of the reason that they were doing the project was they wanted to be able to provision on demand for their end users for new projects. So we talked through with them how they're going to build new environments, what their environment strategy needs to look like in terms of code promotions, how they're going to do their clones, and how they could either have us build or use us as a managed service provider for those use cases. So from a project process perspective, this customer started off in a private cloud solution. The initial process of creating the cloud account, provisioning the infrastructure, was a matter of a week or so to go through that design and deploy process. Building out DR was another few days, getting that replication set up, and making sure that there was a solution that was viable from a disaster recovery perspective. Then the process of migrating the dev and test environments over and building out some additional non-production environments. And then the final phase, which was migrating production over to OCI. So this project took about 6 weeks to get done. That included all the testing. Obviously, working with a partner, they were able to do it very quickly and easily. If you haven't done it before and you're not going to use a partner to do it, you should add another 4 to 6 weeks on top of that to give yourself enough learning curve and some trial and error. Some of the things that they went through around trade-offs between infrastructure as a service and platform as a service. Obviously with infrastructure as a service, it's a fully flexible deployment. You can install the software as you want. You can do with it what you want. You have full control over the environment. You can create multiple Oracle homes in a single VM. You can still use TDE. Whereas in the database cloud service, you get the benefit of having subscription licensing or BYOL. And just to make note that you cannot mix BYOL and subscription licensing in the same database cloud service. So you have to pick one or the other, which is part of the reason I had mentioned before that you need to go through a license analysis and a license optimization process to make sure that you have what you need for your particular use case. One of the other nice things about the database cloud service is it includes licensing, not just for TDE, but also for data masking and subsetting, as well as tuning and diagnostics. So for customers that may not have access to those management packs, using DBCS is a great alternative and gives you some additional capabilities for no additional fee. So even if you're bringing your own licenses or just for Database Enterprise Edition, you'll get all of those things by moving over to Database Cloud Service Enterprise Edition. If you do use Database Cloud Service, you have to use the EBS Cloud Admin tool to migrate that will convert your standalone database to a pluggable database. And as I mentioned, there is a limitation there of one database per instance on VM. Bare metal, you can have as many as you want. And then, obviously there's a decent amount of tooling for things like patching and backups. Obviously with Autonomous, it's fully automated. It doesn't really require any sort of significant DBA effort. So you have that benefit as well. And this customer chose to implement the PaaS solution. I'm not going to talk too much about the EBS Cloud Admin tool versus doing a custom migration, but with any of the Applications Unlimited migration tools, and this includes JD Edwards, which is probably that and eBusiness Suite have the most advanced automation tooling for Apps Unlimited. There are limitations in the use cases. So if you have a complex implementation, the Cloud Admin tool probably isn't going to work for you, and you will have to use a manual solution or a combination of the two. So every use case can be a little bit different. The original source environment in a private cloud had, as I mentioned, database tier, internal and external middle tiers in the red, and user access through a single point of entry into that private cloud data center. The initial purchase of OCI included 11 OCPUs of compute, some block storage, some object storage, a database backup cloud, Fast Connect Partner Edition through Equinix, and about $3,000 a month in Universal Cloud credits. So this customer is running their entire environment in OCI for under $3,000 a month. Some of the storage was actually converted into file storage after we went through the design phase with them. So again, because it's universal credits, you can mix and match that spend however you want. This initial migration was basically for disaster recovery and the development environment. It was done in Phoenix, and all the deployments happened to Database Cloud Service. One thing to note from a load balance perspective in the terminology, you shouldn't think of the load balancer as an actual hardware load balancer. You should think of it as a virtual IP address within a load balancer. So when you actually deploy a load balancer, you're deploying a virtual server, a virtual IP address for a particular application environment. So if you have 5 application environments in your deployment, you have 1 production and 4 non-production, that will be 5 load balancers that you will provision to correspond to each of those 5 environments. So once this was done, they had a split hybrid configuration between production in the private cloud, non-production and disaster recovery in Oracle Cloud Infrastructure, where they set out with the goals of offsite backups, DR, burst environment capacity, and they are getting those results. Nightly backups to OCI, hot replication with DataGuard, and rapid provisioning of new application environments. Second phase of that was production migration. So on the left-hand side, you see the results of phase 1. After production, obviously they got rid of their hardware, higher availability levels, automated provisioning with Terraform in the case of a disaster, significantly improved performance, faster cloning. So overall, they got some significant management benefits. So hopefully this sheds some light on design considerations for Applications Unlimited on OCI. Obviously, this is a massive topic, and I couldn't go into too much depth in any one area, but feel free if you have any questions, please send me an email. My email is listed on the screen there. Thank you everyone for watching, and we'll hope to do this again soon.